Good day again to everyone. So let's now discuss the hyperbola. So far, we have seen the circle, the ellipse, or the parabola, and then the hyperbola. And we have mentioned ellipse. I have mentioned there that those curves will fall under the general second degree equation, and that will now include our hyperbola. Considering the second degree equation for the hyperbola, same thing will happen. The term xy is missing. So let's review. For the circle, xy is missing, a is equal to c. For the parabola, xy is missing, there's only one squared term. For the ellipse, xy is missing, there are two squared terms. A and c will have like signs, but a is not equal to c. Okay, for the hyperbola, still we will have the xy term is missing, and a and c must have unlike signs. Okay, so as long as the signs of a and c are not the same, xy term is missing, then the second degree equation will refer to our hyperbola. So going back to this diagram, we find that the hyperbola is obtained by passing a plane through our circular cone such that the plane will be passing through the circular base and that plane is perpendicular to the circular base. So there will be two sections. Why? Because actually there parang nandyan na yun, symmetrical kasi siya. Okay? And this will now give us the general form of the hyperbola. And then if we have the general form, we also have the standard form. So for this slide, we have used and utilized this slide for the ellipse. And if we will now compare the standard form of the hyperbola with the standard form of the ellipse. So similarly, it would now look something like this, but this time, this will become minus, and then the condition a greater than b will no longer happen. Okay, so in the standard form, still the center will be at hk, but this time we will no longer call this as the major axis, but rather this will be called as our transverse axis parallel to OX. So for the ellipse, you have your major axis and your minor axis. For your hyperbola, you have your transverse axis and your conjugate axis. Okay? So if H and K will be 0, the transverse axis will be on OX. The conjugate axis will be on OY. While if the center is at HK, the transverse axis will be parallel to the x-axis, while the conjugate axis is parallel to the y-axis. So going over the second standard form, this will now be again minus the condition A greater than B will now be removed. Still the center is at HK, and then we change the major axis to transverse. So very similar with the uh, ellipse. But for the ellipse, A is greater than B. So that's our basis, the greater value in the denominator. But this time, for the hyperbola, the first term will be positive, the second term will be negative. The first term will be positive, the second term will be negative. Where you find the positive term, that's where you find your transverse axis. Okay? So the parts of our hyperbola will be similar to the parts of our ellipse. We still have the center HK. We have four vertices AB, A1, A2, B1, B2. We have two foci, F and F1. We have two lateral recta, QQ prime, Q1, Q1 prime. Therefore, we have four ends of the lateral recta, QQ prime, Q1, Q1 prime. We will have two directrices. We have DD prime and then the D1, D1 prime. Same thing will happen if you get the center to A1, center to A2, it will be equal to A. Center to B1, center to B2 would still be equal to B. But again, this time, we don't mind whether A is less than B or A is greater than B or they may be equal. Okay? As long as we're looking at opposite signs here. And then center to focus would still be AE. But this time, our formula will be the square root of A squared plus B squared. So that's another change. Then, if we get the distance from focus to end of latus rectum, still it will be B squared over A. Center to the directrix is A over. Okay, so same analysis. Now, if we will try to draw our hyperbola. So let's say we would like to use the diagram for the hyperbola wherein the transverse axis is parallel to the x-axis. So if we will try to draw that, so let's say our center is here, but before we have that, let's have our Cartesian plane first. So let's say this will be our y-axis, and then let's say this is our x-axis. Let's draw our x-axis. Let's say this is our x-axis. Now we proceed with our parts. Let's say this is our center HK. Therefore, this will now be, let's just complete the label. This is our center insert. So that's H, and then our K will be here. Just complete the label. So this will now be H, and then this will now be K. So if you will observe in our previous conics, we have always based our distances for the vertices, for the foci, for the ends of the latus rectum from H and K. Okay, and then we now have our, let's say, since we are considering transverse axis parallel to the x-axis, so this is our x-axis, our y-axis. So let's say we have the ends. Let's say this is our A1. Therefore, A2 is here. And then let's say B1 is somewhere here. Then B2 is somewhere here. Let me change the location of B1. Let me just adjust that. So that's B2. Let's say B1 is here. So what do we know about this? distance from center to A1 is A. Distance from center to B1 is B. Therefore, if we will now have our values, this will now be for A1, and for B1, that will be the abscissa, and then this will now be the ordinate for B1. Oops, what happened there? Let me just bring that back. It's B1, that's B2. Okay, there you have it. So if we are now after the coordinates of A1, if we are now after the coordinates of A1, then this section here will be for the abscissa of A1, which is H plus A. Isn't it that this is A? So this is H plus A. While for the ordinate of B, this will be K plus the value there is B. So if you will try to list down, your A1 is at H plus A, and then the ordinate will be the same as the ordinate of C, which is K. So if our points are on the same horizontal line, the ordinate will be the same. If the points are on the same vertical line, then the abscissa will be the same. So A2 is to the left, so this is H minus A, K, while B1, B2, B1, B2, they are lying on the same vertical line with the center, therefore they must have the same abscissa, H and H. Ordinate, this is K plus B. This is below K minus B. And then after our vertices, we will have our foci, F and F1. So take note of this. This is very important now. For our F and F1, they will lie on the transverse axis. So the transverse axis here is the line passing through A1 and A2. But this time, F and F1 will be located farther from the center compared to A1 and A2. So we can have here, let's say F, and then F1 is located somewhere here. Okay, wherein the distance from center to F is AE. So the distance from center to F is now farther from distance from center to A. Okay, and so if we will now look at the abscissa of F, it will be this entire thing here, which is H plus AE. So that's the abscissa of F. It will be H plus AE. F1 is to the left, H minus AE. And then for the ordinate, they lie on the same horizontal line with C, so they must have the same ordinate with C, which is K. And then after our foci, we now look at the ends of the lateral recta Q, Q prime, Q1, Q1 prime. Where do we locate our Q, Q prime? They will now be located if we will now draw lines perpendicular, passing through F perpendicular to the transverse axis. Let's insert that line, those lines first. So let's say we have this as one of the lines, and then Let's draw another line passing through A2 this time, perpendicular to the transverse axis. So we can now label the endpoints there with Q, Q prime, Q1, Q1 prime. But before we proceed, forgive me for this one. It should be drawn here, passing through F, not passing through A2. Where is our F here? This is our F. So, it should be here. Not this one. Let me remove that. Okay. So, we have our labels there. So, before we proceed, there's one more thing that will be added for our hyperbola. And what is that? If we will now draw lines passing through the vertices, so that's a line passing through B1, a line passing through B2, a line passing through A2, a line passing through 1, 2, 3, 4, 1, 2, 3, 4, A2. Okay, and then if we now draw the lines connecting the diagonals of those, let me extend that. And then let me also draw the line, this time connecting these diagonals. These lines are called asymptotes, which we did not find under the ellipse. So these are called asymptotes. And what are asymptotes? Asymptotes are actually boundary lines. Boundary lines, okay? So how do we now draw our hyperbola? So if we will draw our hyperbola, one portion of the hyperbola will be from A, we connect it with Q, and then A1, we connect it with Q prime, and then A2, we connect it with Q1, A2 connected with Q1 prime. So it looks like we have two parabolas. And then the asymptotes, these are boundary lines, meaning this portion of our hyperbola will not cross this asymptote. Similarly, this one will also not cross our asymptote. And together with this. Okay? And then our directrices, where do we find our directrices? This time, our directrices will be nearer to the center compared to the value of A1 and A2, or the location of A1 and A2. Okay, so there you have completed all the parts, and still the distance from center to the directrix is A over. Okay, so by the way, we did not yet complete the list here. So if you will now go over the coordinates of Q, same vertical line with F. So this is H plus AE. Q prime. So this is H plus AE also. This will now be H minus AE. This will be H minus AE. Coordinate will be F. This distance from F to Q is B squared over A. So that will now be K plus B squared over A. This is below K minus B squared over A. This is K plus B squared over A as well. And then K minus B squared over A. So again, take note. If points lie on the same vertical line, they will have the same abscissa. If points lie on the same horizontal line, they will have the same ordinate. And then finally, for our directrices DD prime, where's the pen? DD prime will be a line parallel to the y-axis, so it will be x equals h, that's h plus a over e, while d1 prime will be x equals h minus a over e. Of course, if your hyperbola will now be having its transverse axis parallel to OY, then you have to change the orientation. But anyway, at least you have here how you already have here the parts and how to locate those points. So let's look at an example. Let's have this equation. This is a problem given in your module. So you have 9y squared minus 4x squared plus 8 minus 8x minus 36y minus 4 is equal to 0. The xy term is missing. Coefficient of y squared, coefficient of x squared, opposite sign. So this must be a hyperbola. So what will be the first step? So like for the ellipse, the first step is let's put all the terms. So in this case, involving y squared and y together, x squared and x together, and then we isolate the constant. So after isolating the constant, we make the coefficient of y squared be equal to 1. So we factor out 9 for the terms involving, so this is 36, by the way, 36 divided by 9 will be 4. And then, making the coefficient of x squared equal to positive 1, we factor out minus 4. So that will be x squared plus 2x. Again, we have factored out minus 4. And then the right side is 4. Completing now the squares. Completing the squares. So we always add. 4 divided by 2 is 2. We square it. 2 divided by 2 is 1. We square it. This will be plus 9. Plus 9 times 2 squared. Here, don't forget the minus sign. Minus 4 times 1 squared. So very similar with your ellipse. Then we factor 9 times, copy the base, copy the sign, copy the base, everything raised to 2, minus 4, copy the base, copy the sign, copy the base, everything raised to 2. Then simplify the right side, that will be 4 plus 4 times 9 is 36. That will be 1 times minus 4 is minus 4. 4 minus 4 will be 0. And then the standard form, right side must be equal to 1. So if we will just rewrite this, this is 9 times y minus 2, the quantity squared, minus 4 times x plus 1, the quantity squared, equals 36. To produce now positive 1 on the right side, we divide both sides of the equation by 36. So this will now be equal to 1. The left side, what do we get? We have y minus 2, the quantity squared, over 9 and 36 will cancel out. That should be 4. And then minus x plus 1, the quantity squared, all over 36 divided by 4 will be 9. So where is the positive sign? It's with y. Minus sign is with x. So if you will describe this, you have your hyperbola with center at hk, x minus h. So minus 1. Y minus k. That will be 2. So that's the center. And then transverse axis parallel to the y-axis, or that's OY, because the positive is with y. Okay, so center is at minus 1, 2. This will now be your a squared. This will now be your b squared. Center is at minus 1, 2. center minus 1, 2, and then we have a squared is 4, b squared is 9. So if we will now draw our dummy graph, I think we better use the next slide. If we will draw the dummy graph, again, the center is at minus 2, minus 1, 2, minus 1, 2, 4, 9, minus 2, minus 1, 2, minus 1, 2 is the center, a squared is 4, b squared is 9. Remember, transverse axis parallel to OY. Let's draw now our dummy graph. This will be our dummy graph. Let's use the first quadrant as reference for our dummy graph. It's easier to use the first quadrant because the terms in the first quadrant will be positive. It will not be confusing. Okay, center. Center, let's say, is here. It's at HK. So use HK first. Transverse axis parallel to OY. So this will be your A1. And then your A2 is located somewhere here. And then this will now be the location, let's say, of your how many? 1, 2, 3, 4, 5. I'm not using the exact values in the problem yet, okay? There you go. So what do we know? Center to A1 is A. Center to B1 is B. Let's list down our values. A1, A2, B1, B2, A1, abscissa. This will now be, if you will drop a perpendicular line going to the y-axis. So let's drop a perpendicular line to the y-axis. Same vertical line with the center. And then if you now draw a perpendicular line from A going to the y-axis, you get the following values. This will now be H. This will now be, remember this is K. So this is K plus A. Then this is H. So you have H, A2, H also. This is K plus A. This is below K minus A. For B1, it will be H plus B. To the left, H minus B. Same horizontal line, so they must have the same ordinate with the center, K and K. So you have your vertices now. Next, your foci. Your foci, they will be located farther from your A1 and A2. So let's say this will now be our F. And then let's say F1 is here. F1 is here. What do we know? Center to F is AE. So, pareho sila ng vertical line with the center, H. This will be K. Diba? This will be K plus AE below K minus AE. And then after that, you now have your ends of lateral recta, Q prime, Q1 prime. And where do we draw our lateral recta? It will always be perpendicular to your transverse axis. So this will now be 1 lateral recta, or latus rectum I mean, through F. So this is another latus rectum. So if you label, remember the labels, you can actually place them anywhere. If you would like to interchange the labels, it's okay. Just make sure you will be very careful as you list down the coordinates. That's Q, Q prime. If you like Q here, Q prime there, there's no problem with that. This is Q1, Q1 prime. What do we know? F to Q is B squared over A. So, if you will now draw your coordinates, Q, wala siyang kalinya, except for Q prime. So, that must be H plus B squared over A. Alin ang kalinya niyan? Q and Q prime. So, H plus B squared over A. To the left, H minus B squared over A. This is H minus B squared over A. And then for their ordinates, ito pareho nung same horizontal line sila with F. Diba? So, K plus AE, K plus AE. This is now K minus AE. Below kasi sila, K minus AE. And then for our directrices, D prime and D1 prime. But before we do that, sige, kompletuhin muna natin yung diagram natin. Kunin natin yung rectangle na mabubuo from kina A1 so, ayan, dadan kay A2 dadan kay B1, B2. Okay. So that's the rectangle. Guide natin yung rectangle na yan. Now let's draw the diagonals. That's one diagonal. Let's draw the second diagonal. That's the second diagonal. Okay. So, dami graph lang naman to. Kaya kung i-draw na natin yung ating hyperbola, one portion will be this one. Okay. The other portion will now be this one. There you have it. And then, yung directrices natin, one directrix will be going this way, the other directrix will be going this way. So we can call this as D prime, D1 prime. And what do we know? From center, the directrix is A over A. Kaya, kung isusulat na natin yung equation niyan, parallel with the x-axis, so that must be y equals k plus a over e. This is k minus a over e. And, ibig sabihin, ang a1 natin will be at h. Anong h? H is minus 1. K, 2. Ang A natin, 2. Ang B natin, 3. H natin is minus 1. K natin is 2. 2, K is 2 plus A. 2 plus 2, 4. And then, A2 will be at -1, 2 minus 2, 0. B1, H plus B minus 1 plus 3. -1 plus 3, 2. Tapos ang K natin, 2. Tapos si B2, H minus B. H is -1, -3, -4. And then 2. Tapos si F will be at H. H is -1. And then AE. Ano ba si AE? Di ba ang AE is the square root of A squared plus B squared. Yung sa ellipse, minus yon. Sa hyperbola, plus. A squared is 4, B squared is 9. So this is the square root of 13. Square root of 13 yan. So, anong K natin? K is 2 plus the square root of 13. Of course, pag may calculator kayo, i-compute nyo na lang yan. That will now be 2 minus the square root of 13. And then, here, anong kailangan natin? B squared over A. So, ano si B squared over A? B squared is 9. A is 2. 9 halves. So, Q will be located at H minus 1 plus 9 halves. Ano ba si 9 halves? That's 4 and 1 half minus 1, 3 and 1 half. 3 and 1 half, or that's 7 halves. 7 halves yan, no?